part is inalam yung initial moisture content ng potato and sweet potato using the AOAC method. So, AOAC method, yung formula niya is yung moisture content equals weight before dehydration minus weight after dehydration over weight before dehydration times 100. So, for the second part is yung sorption isotherms. Dito naman, yung equilibrium isotherm data was determined using gravimetric method. The samples were allowed to equilibrate and the moisture content was determined and correlate by Guggenheim-Anderson-Debord equation. So, X is the equilibrium moisture content equals yung monolayer equilibrium content times yung C tsaka yung K is yung isotherm parameter times the water activity over this. Next is yung determination of thermodynamic properties. So differential enthalpy or delta H provides an indication of the state of the adsorbed water and hence a measure of the physical, chemical, and microbiological stabilities under determined storage conditions. Tapos, in delta S naman, or in differential entropy, is related to the number of absorption sites for a determined energy level inherent to the biological material. So, dito, yung differential enthalpy and entropy was determined using Clausius-Clapeyron equation. So, kapag in-integrate itong Clausius-Clapeyron equation, makuha yung equation na to. Where dito, na-relate na yung delta H tsaka delta S using yung water activity. Next is the enthalpy-entropy compensation theory. Compensation theory is used to evaluate physical and chemical phenomena such as sorption reactions. So dito, kinuha yung isokinetic temperature and mean experimental temperature. Using mean harmonic temperature. Itong dalawa may relation siya na i-discuss later. So, yung isokinetic temperature, kinuha siya para makuha yung differential enthalpy. Next is the spreading pressure. The spreading pressure represents the excess of free energy at the surface tension absorption sites due to sorbed molecules. So, ito yung formula for the spreading pressure, where Kb is the Boltzmann constant and Am is the surface area of the water molecule. Last is the net integral enthalpy and entropy. So, net integral entropy and enthalpy are used to explain the behavior adsorption mode for biological materials. Integral entropy describes the degree of disorder or randomness of motion of the water molecules. So, ito yung formula for the net integral enthalpy and entropy, where ang spreading pressure niya is constant.
Next is the data and results of the research. So, these are the experiment results obtained for the equilibrium moisture content of potato and sweet potato flakes. So, AW represents the water activity, and X is the moisture content, equilibrium moisture content in distinct isotherms like 15 degrees, 20 degrees, 25 degrees, and 30 degrees. So, next, they compute for the differential enthalpy and entropy. So, the values for differential enthalpy were calculated for potato and sweet potato flakes as a function of moisture content. So, in y-axis, yung differential enthalpy, kilojoules per mole, and yung x is moisture, kilogram water per kilogram dry basis. So the explanation for this is in the difference occurring between the hydrogen bonds as water is adsorbed, in the force of attraction between the adsorbed water molecules and the sorption sites, and between the water molecules themselves. So as the moisture content of the product increases, the heat of sorption decreases due to a reduction in the interaction between the water and other molecules in the system. So the next one is the differential entropy of adsorption in sweet potato. So let's get back to the differential enthalpy. So as you can see in the graph, the values for differential enthalpy were higher for the sweet potato, indicating the existence of more polar sites on the surface of the solid and greater bonding energy between the water molecules and the surface, thus requiring more energy to dry the product. Sige. So, the next one is differential entropy of adsorption of potato and sweet potato flakes as a function of equilibrium moisture content. So, the circle one is the potato and the triangle is the sweet potato. So, then in y-axis again, it is the differential enthalpy kilojoules per mole, and in x-axis, the moisture kilogram water per kilogram dry basis. So, the differential entropy of a food is proportional to the number of sorption sites available at a determined energy level and as adsorption occurs throughout the product. So, specific sites become filled by water molecules such that the entropy associated with the still vacant sites become smaller and smaller. So, yung sinabi nga ni Sir Tards na habang tumatagal and habang mas dumadami yung nag-a-adsorb sa surface, mas nagiging matagal para dun sa mga susunod na mag-adhere sa surface kasi mauubusan sila ng binding site. So, as can be seen, the GAB equation describes the experimental data well to two products throughout the range of temperature studied, with low mean relative deviation modulus between 1.2 to 4 and 4% and coefficient of determination of 0.99. So, this is the product and the distinct parameters that Rowie has talked about earlier, and the distinct temperatures and the average. So next is the enthalpy and entropy compensation theory. So the compensatory theory proposes the existence of a linear relationship between the enthalpy and entropy of products submitted to a water adsorption process. So dapat ang makikita daw natin is linear yung pag ginraph yung differential entropy and enthalpy para ma-confirm yung compensatory theory. So, sa compensatory theory, dapat pareho din yung mean harmonic temperature and isokinetic temperatures. So, ayun yung natakil ni Rowie kanina. And mean harmonic temperatures, may kita yon sa kinakalculate na equation. Yung isokinetic temperatures naman, may makakalculate siya via linear reg gamit yung experimental. So, the delta G for potato is 355.75 joules per mole, and it's 340.57 joules per mole for sweet potato. So, we can see that delta G is positive. So, it is a non-spontaneous process. It needs energy and etc. So, delta G also indicates the affinity of material for water. So, let's get back earlier for the compensation theory. So, the calculated equation is for potato is 334 joules per mole, and the isokinetic temperature for potato is 372.8, and for sweet potato 354.91 joules per mole for the mean harmonic temperature, and for the other one is 421 joules per mole for sweet potato. So, since isokinetic, the harmonic temperature process is controlled by the enthalpy, while if harmonic mean temperature is greater than isokinetic temperature, the process is controlled by entropy. So for the spreading pressure, it can be seen that the spreading pressure increased with water activity for all the temperatures studied, but there was little effect of temperature on the values for spreading pressure, as already shown for potato. The spreading pressure represents the excess of free energy at the surface and provides an indication of the increase in surface tension at sorption sites due to sorbed molecules. So for the net integral enthalpy and entropy, so the values for net integral enthalpy increased in moisture content. So it was due to the fact that at low moisture values, the water is absorbed at the more accessible sites on the external surface of the solid. So with the increase in moisture content, the material swells up, thus opening new high energy places for the water to bind, such that the net integral enthalpy increases until the stronger binding sites are covered. It can also be seen that the sweet potato flakes showed higher values for enthalpy than that potato flakes, indicating that this product had more highly polar primary adsorption sites on the surface of the material. So this one is the graph of the net integral entropy. So it shows that the decrease in net integral entropy with increase in moisture content, and the lower values obtained for the entropy of the sweet potato flakes. This was attributed to the increase in water molecule mobility as the available adsorption sites become saturated. So, the loss in entropy shows the loss of rotational freedom or degree of randomness of the water molecules due to the strong binding of the sites to the water molecules and solids. So, and it was also shown that for the moisture range evaluated, the values for integral entropy were negative, attributed to chemical adsorption and or structural modification of the adsorbent.
So for the conclusion, the thermodynamic analysis of the experimental sorption data for potato and sweet potato flakes showed that both the differential enthalpy and entropy decreased with increase in moisture content, proving the adequacy of applying the enthalpy-entropy compensatory theory to the two samples, and showing that the sorption mechanism was governed by enthalpy. The values found for Gibbs free energy were positive, showing that the process was not spontaneous.
So, the net integral enthalpy increased with moisture content, whereas the net integral entropy showed the opposite effect, presenting the negative values.
So,
So,
that's the end of our presentation.